In this video, we're going to look at solving some integration problems that have initial conditions. And so when we're solving these, we're not just trying to find a general solution, we want to find a specific solution. So we won't have a plus c in our final answer, we'll have an actual number in place of that value c. All right, so let's look at an example. Here we want to find the function f of x that satisfies the given conditions. Its derivative, f prime of x, is 12x squared plus 2, and it satisfies this initial condition. When we plug 1 into f, not into the derivative, but into f, the output should be 2. So this is called an initial condition. And we will use that in a moment. But first, let's deal with the derivative. So let's use that derivative, f prime of x. Let's use that to find f of x. So we're going to integrate 12x squared plus 2. And we're going to integrate that with respect to x. When we integrate that, we will use our integration rules. So we would have that x squared, add 1 to the power 3, divide by the new power. 12 divided by 3 is 4. 2 will integrate to 2x. And then we have the plus c. Now I know I mentioned earlier that we don't want to have a plus c. We won't have that in our final answer. Right now, this is just a general solution. So what are we going to do? Let's use the initial condition to find c. So our initial condition tells us if we plug 1 into our function f, then the output should be 2. Well, right here, this is going to be our function f. Right? We integrated f of x, f prime of x, so this is our function f. And so when we plug in 1, f of 1 is going to be equal to 4 times 1 cubed plus 2 times 1 plus c. We want that to be equal to have an output of 2. So 4 plus 2 plus c is equal to 2. And then we would solve that and get c is equal to -4. Are we done? Not quite. Now we need to just put it all together. So our particular solution it's also called a specific solution. It's going to be f of x is equal to, so this was the function, 4x cubed plus 2x, but in place of c, we're going to plug in this specific value of c, this particular value of c. So we have found a particular solution, a specific solution. Excellent. Let's look at a second example. So here we want to find the function g of x that satisfies the given conditions. So here we're starting with a second derivative, and they tell us the derivative at 0 and the function value at 0, the derivative at 0, and the function value at 0. All right, so here we have, if we were to integrate the second derivative of x, so g prime of x is going to be the integral of x squared dx. If you were to integrate that, you will add 1 to the power, divide by the new power. Plus c. Now, what do we know about the derivative? Well, we know that g prime at 0 is equal to 8. So 1/3 times 0 cubed plus c is equal to 8. So c is 8. And actually, I might call this c1, just so later on we're going to see another c, and it doesn't get confusing which c we're referring to. And so now, at this point, we know that g prime of x is 1/3 x cubed plus 8. And we're trying to get to g of x itself, and so we're going to integrate again. G of x is the integral of 1/3 x cubed plus 8 dx. So that x will add 1 to the power, divide by the new power. We already had the 1/3, and so we have a 1/12 plus 8x plus some other constant. Could be the same constant, we just don't know. And we know if we were to plug in 0 here, the output should be 4. So 1/12 times 0 to the 4th plus 8 times 0 plus c2 is equal to 4. So c2 is equal to 4. And so we've gone through all that to find g of x is 1/12 x to the 4th plus 8x plus 4. And that is our specific solution. Excellent. Come back for our next video when we'll look at one more example that deals with velocity and acceleration. So some specific physics kinds of applications. We will see you there.